Hello, my name is DJ and I'm learning about clustering by experimenting with Raspberry Pis. In this particular episode, we're going to be finding the Pis on the network. Now, this relates to a series of posts and accompanying YouTube videos I've got in this Brambleweenie Cluster Experiments blog post here. They're listed down here. This particular episode follows the previous one, which is where we prepared the operating system images. And there's an accompanying YouTube video as well. I went through and described how I downloaded the image and mounted it and created a bootable SD card based image that I could access the machines through over the network by adding an SSH file and so on. So have a look at that to find out how we did that. So effectively what I've got now is a cluster of 4 Raspberry Pis into which I've inserted an SD card with the image that we prepared following this blog post. But the problem now is that these Raspberry Pis are on the network and they're up and running. They're headless. The only cable I've got connected is are the network cables here, because I'm running power over Ethernet to power them as well. And we don't know what their IP addresses are. And we need to identify them from a network perspective so that we can start configuring them and administering them and connecting to them also from here over the network. So in this blog post here, I described the fact that I'm using Google Wi-Fi, which is great, although the Android-based app that you get to administer the network, it's okay. It's not particularly helpful if you want to do this sort of thing. So the better option for me is to use some command line tools. And one of the tools that I describe in the blog post is Nmap. Now Nmap, let's just move this over here. Nmap is a network exploration tool and a security scanner, a report scanner. We're just going to use a really simple feature of Nmap, which is basically to scan for IP addresses. Nmap SN 192.168.86.0/24. Now that particular argument there is the identification of the network here, of the subnetwork on this home lab here at home. So as many folks who run Google Wi-Fi will know, the default subnet is 192.168.86, and then of course it's a network or a subnet with 24 bits as the network mask, which basically means that that's the network identification part of an IP address, and this is the host identification part of the IP address. So all my hosts are going to be .1, .2, .3, .4, .5, and so on. So let's run that and find out to see what it will show us here in terms of hosts it finds on the network. You can see I've got some Nest devices, I've got Amazon Fire Stick, Chromecast, and so on. And I can see here that it's found a device that's identifying itself as Raspberry Pi.LAN. So that's likely to be one of these 4 devices here, but I'm not sure where the other ones are. And also, because we're going to be using Ansible to connect to, configure and administer these 4 Raspberry Pis in the cluster, we're going to want to be more specific in identifying these Raspberry Pis. And a better way to do that is to identify them not via their IP addresses, but via the MAC addresses. The MAC addresses are addresses that are specifically tied to network interfaces. So a device will have 1 or more network interfaces. These Raspberry Pis have 2 network interfaces that I'm aware of. The Ethernet network interface here that this one's plugged into, and also a Wi-Fi network interface. But I'm only using the Ethernet, so the MAC address will do in this case. And I've gone through already and found out what the MAC addresses are. I'm just working through that now with you. And one of the things that's really nice is that from an Ansible configuration perspective, I can say, well, the device with the MAC address 95, I want to give the host name Brambleweenie1, and I want to give it this IP address. And the the device with MAC address 77. I want to give it the host name Bramble-Greeley 2 and this IP address here, 13, for example. So that configuration file is what we want to eventually create and use. But before we do that, we've got to find what these MAC addresses are. So instead of using Nmap, I ended up using ARPScan. Now, ARPScan is, well, as it says in the man page, an ARP scanner, address resolution protocol scanner. So address resolution protocol is part of the IP protocol suite, runs at a lower level than TCP/IP, as far as I'm aware. I'm not a networking expert. What this will do for us, effectively though, is it will give us a little bit more information about the devices on the network. It's actually a system utility, so I'm going to run it as root. So let's specify the network again, 86.86.0/24, and see what it gives us. Did I not do that right? ARPScan 192.192.186. Oh, sorry, 168. 168. How often I've typed that, I don't know in my life. Many, many times, and got it wrong there. There we go. Okay, so this gives us, first of all, a lot nicer output, a lot more readable output, and it gives us IP addresses and MAC addresses. So we can see here Raspberry Pi. I've got a number of Raspberry Pis. So that's a little bit better. Now we can go one stage further and say, well, let's just cut out the noise and just break it down to what we think are Raspberry Pis. Now, in the blog post here, we can see that I've got a link here to a canonical list of OUIs, organizationally unique identifiers. What are OUIs? Well, basically, if you look at the first three numbers of any given MAC address, the sort of colon separated numbers, they effectively represent the hardware manufacturer. And there's a list here of OUIs at IEEE.org. And if we search for Raspberry Pi, we'll see that there's actually a couple of entries in here. We'll stick to this one because this is the one. We'll see that Raspberry Pi trading in Maurice Wilkes building in Cambridge is identified from a hardware manufacturing perspective by DC-A632. We can see already DC-A632, and there's probably some more. There we go. There's another one. DC-A632, unknown in this case. I'm not sure why it's unknown. But that's the whole point. You know, we can be more specific by looking at the MAC address and the details of the MAC address. So maybe the next thing we want to do is to do that again and say, well, let's just search for all the ones with D6. What was it? DC-A632. And there we can see that we've got already a lot nicer output. Now I know for a fact that somewhere, I've got it written down there somewhere, yeah, I've got the Raspberry Pi 4 that's behind this monitor that I'm running a different distribution on. I know that address is 49, so we can discount this one. So now we know that the 4 Raspberry Pis in this cluster here have these IP addresses, have been given these IP addresses by the DHCP server on the network, and I'm running DHCP not from the Google Wi-Fi router anymore, but from my Pi-hole that's running on a Raspberry Pi Zero, but that's another story. So we can identify now that the 4 Raspberry Pis in this cluster have MAC addresses that end in 77, 95, E3 and 44 and are currently with these particular IP addresses assigned to them. So that's great. We found the MAC addresses, and now what that means is that we can, in our networking setup from a Ansible perspective, we can go and add those IP addresses into the inventory, because in the next episode we're going to be using Ansible and pointing Ansible at those 4 devices. And of course, before we configure them to have different IP addresses, they're going to have these IP addresses. So the output that we saw here with these IP addresses 15, 47, 125 and 158, I've put into the inventory called the collection of IP addresses, given it a name, Brambleweenie. And I've also configured something else as well, which we'll look at in the next episode. So that's pretty much it. We've got the OS on SD cards, we've inserted the SD cards, we've booted up the Raspberry Pis, they're on the network, we've found them on the network, and we've managed to find not only their MAC address with which we can configure what we want them to be from an Ansible perspective, and that's in the next episode, but also we've got the IP addresses so that we can actually start to connect to them. Okay, that's all for now. Thanks for watching.